Right, so welcome. Today we'll be looking at how to sketch quadratic functions. So the general form of a quadratic function will be in this way. So f of x will be equals to ax squared plus bx plus c. So this is the general form of a quadratic equation. And then what I want you to know is that f of x, this f of x here, is the same as y. So I can also write this equation as y is equals to ax squared plus bx plus c. Okay, so whenever you see f of x, it's the same as what? Y. Okay, so when we sketch these quadratic functions, we're going to be sketching them on the xy plane. So they'll be looking something like this. Okay, so I'll draw about 3 samples of them. So if this is my y-axis, then I have my x, y-axis, then I have my x, y-axis, and then I have my x. So it's very easy to sketch quadratic functions, but you just have to know the rules and what to find. Okay, so we're saying this is our y, this is my x, this is still my y, this is my x, y, and then x. Okay, so one of the forms of the quadratic equation, okay, it can be in this way. You can find something like this. Okay, so a quadratic equation, it is a curve and it's not a straight line. It can be in that form, or you can have something like this. Okay, let me draw it like this. You can have something like this. Okay, or we can have something like this. So you notice that this first graph, I'm going to call this one. This one should be 2, then this one is 3. So this graph on 1, okay, you notice that it touches the x-axis at 2 points. Okay, touches the x-axis at 2 points. There is 1, this point here, and then 2, that point. Okay, and then it touches the y-axis at 1 point. And then also it has a turning point where it's turning. You can see here, it's coming from on top, it's going down, down, down. And then there's this point here where it turns and starts going up. So we call this point here, the lowest point on this graph, we call it the turning point. So we're going to indicate it by TP. Okay. And these same things are the things that we're going to find here. We have 2 points where this graph is meeting the X, and then I have 1 point where it's meeting the Y, okay? And then I have this point on top here where the graph is turning, because here it was going up, up, and then it starts going down. So this part here, we're going to call it as the turning point, okay? And then this one, maybe I should be labeling it. It's what we call as the y-intercept. So I'll just write y-inter. And then these two here are what we call as x-intercepts. Okay, so it should be the same even for these ones. So these are x-intercepts. This one is the y-intercept. And then that one there is a turning point. Okay, and then when I come here, what do I notice? Okay, so maybe I should extend this graph. Should come like, okay, I should extend it a bit. Should come like that. Okay, like that. So we notice that it touches the the y-axis at 1 point. So we're calling that as the y-intercept. Okay. And then we have this graph here. It's coming to touch the x-axis at only 1 point there. Okay. And this same 1 point is going to act as the x-intercept. And it's also the turning point. You can see that it's just coming to touch the graph here. So where it touches there, it's the x-intercept and it's also the turning point. So why am I drawing these graphs here? Okay, so these simple illustrations of the graphs, they are here to show you that for you to sketch a quadratic function, okay, you only need how many things? 3. Okay, you need 1, the x-intercepts. These ones here, where the curve will be touching the x-axis, okay? 2, you need the y-intercept, okay? Where the curve will be touching the y-axis. And then 3, you need the turning point, where the curve is going to turn. If it's going up, where is it turning to start going down? If it's going down, where is it turning to start going what? Up. Okay, so you always have the y-intercept and you always have the turning point. But the x-intercept, okay, in some case, we are going to see that there will be no x-intercept, okay? There will just be the turning point and the y-intercept. Okay, so if I can just draw a small graph here. So if this is my y, and then this is my x, we also have situations where we have a graph such as this. So a graph is coming, okay, from here, and then it goes, okay, let me draw it like that. So we also have a quadratic equation that will look like that. So we see that here we have our y-intercept, right? And then there at the lowest point, we have the turning point. But do we have any point where this yellow curve here is touching the x-axis? We do not have, okay? So in this case, we are going to say that this graph does not have any uh, real x-intercepts, okay? All right, so those are the things that you need in order to graph a quadratic function, okay? So now I'm going to explain how we find each of these points, how to find the x-intercepts, how to find the y-intercept, and how to find the what? The turning point. Okay, so let's erase this. So if you have any questions, guys, please, okay? Just say, I don't understand there, and then I'll be able to explain. So we start with the x-intercepts. Okay, starts with the x-intercepts. So for you to find the x-intercepts, you set your y or your f of x to be equals to what? To be equals to 0. Okay, so in short, you're just now going to have a quadratic equation like ax squared plus bx plus c, but now this y is 0. If you're using f of x, you're also saying it's 0. So this is going to be equals to what? To 0. So you solve this quadratic equation, okay, using the factor method, the formula method, or the quadratic formula, whichever method you are comfortable with. And then you're going to find your what? Your x-intercept. And then how do we find our y-intercept? Okay, so our y-intercept is not hard. As long as you have a quadratic equation that is in this form, okay, then the y-intercept will always be this constant c here, the one that does not have any x. Okay, but if you want to show it, how you calculate it, you set your x to be equals to 0. So it means in this equation here, where there's x there, we put 0, here we put 0, here we put 0. What are we going to remain with? We're just going to remain with c, right? Okay, so the y-intercept is just equals to c. Okay, so that's how we find the y-intercept. And then what about the turning points? How do we find them? Okay, so the turning points, we have to use some formulas. Okay, so the turning point is in the form x comma y. So there's the x coordinate of a turning point and the y coordinate of a turning point. So how do you find the x coordinate of a turning point? You use this formula. Okay, so from your quadratic equation, you're going to say my x coordinate of a turning point is actually equals to minus b over what? 2a. This will be your x coordinate of a turning point. So where do you get your b and your a? From the quadratic equation that you've been given there. Okay, and then how do you find this y coordinate of a turning point? So you say y is equals to f of minus b over 2a. Okay, so first of all, you find the x coordinate of a turning point, and then once you have it, you replace that value into this function here in order to find your y coordinate of a turning point. Okay, so there it would have mean that you found your x-intercept. Okay, you found your y-intercept, you found your turning point. So you just come now on the graph here, you plot wherever those points are. So for example, if my x-coordinate, my x-intercept is this one, and maybe that one, okay, and my turning point is somewhere there, and then my y-intercept is somewhere there. Once you plot these points, you just connect them with a smooth curve like that. Then you have your what? Your quadratic function. So this is the general way of how we are going to be what? Solving the, how we're going to be sketching the quadratic functions. Okay. And then another way in which we can solve these, in which we can sketch these quadratic functions, okay, is to complete the square. Okay, so now when you complete the square, you're always going to end up with a certain form. Okay, so I can erase this. So if you have any questions, please ask. So this is my quadratic equation, right? So we can complete the square here, and then we can express this quadratic equation in another form. So that form will be a x plus p squared and then plus q. Okay, so when we complete the square on this guy here, we're going to end up with this. Okay, we're going to end up with this. So let me be consistent with the letters that I use. So there inside, I should write B because I used B here and then there's C. So it will be something like this. Okay, when we complete the square on this one, to be this. So I'm going to show you how to complete the square. It's a very simple method. Okay, and then from this function where I've completed the square, okay, I can find my y-intercept, my x-intercept, and I can also find my what else did we say? I can also find my turning point. Okay, so I'll start with the turning point. So to find the turning point, the x coordinate of the turning point will be equals to, you get whatever is in the brackets here, you equate it to 0, and then you solve for x. So in this case, my turning point will be minus b, like in general. Okay, so you get whatever is in the brackets, you equate it to 0, and then you get the x. Okay, this will be the x coordinate of a turning point. And then to get the y coordinate of a turning point, you're just going to get whatever is outside here. Okay, so you're just going to get that c. That will be your y coordinate of a what? Of a turning point. And then to get the x-intercept, okay, we said we just let f of x to be 0, f of x the same as y. So here we put 0, and then we try to solve this equation that we have. We get two values for the x, okay? In some questions, you are not going to find any values for the x, so it means that graph won't touch the x-axis. And then for us to find the y-intercept, we said we let x to be equals to 0. So here we put 0, where there's x, even here we put 0. And then whatever remains here will be our what? Our y-intercept. Okay, so I've explained the theory. If you have any questions, please ask. Okay, otherwise I'm now going to give an example. We shall solve it first the usual way. Okay, and then we use the completing the square one. So you will see later that completing the square one is much better. Okay, so let's give an example. Okay, so let's say you've been given the following function. Been given f of x is equals to, okay, x squared minus 5x plus 6. And then they've told you to sketch, okay, sketch this quadratic function. What are you going to do? Okay, so the first thing is to find the x-intercept. Okay, so we are using the general way. So if you're finding the x-intercepts, we said you let what? Y or f of x to be equals to what? To 0. So if f of x is equals to 0, then here I'll have 0 is equals to this, right? Which is the same as the x squared minus 5x plus 6 is equals to 0. So I've just started with the function. Okay, and then here we can solve this quadratic equation. So we can solve it using any method that you are good with. So let's solve it using the factor method. So I say product factor sum. So the product is the coefficient of x squared multiplied by a constant. So the product is 6. Okay, the sum is the coefficient of x. So it's minus 5. And then we look for the factors now. So what two numbers can we add to get the minus 5? But when we multiply them, we get a 6. That will be minus 2 and minus what? 3. So here we're going to say x squared, okay, minus 2x minus 3x. This gives me 5x, you've seen, right? So we're just writing this in a special way. And then plus 6 is equals to 0. From here, we're going just to group. So this x squared goes the minus 2x, the minus 3x goes with the 6. So what is common in this bracket? Okay, it's the x. And then I remain with x minus 2. What is common in here? It's the minus 3. Okay, so it means here I'll just remain with x. And then here I'll remain with minus 2 is equals to 0. So it means I have x minus 2 and then x minus 3 is equals to 0. So when I equate this one, I'll get x is equals to 2. When I equate this one to 0, I'll get x is equals to what? 3. So these ones here will be our what? Our x-intercepts. Okay? So it means the curve has to pass at 2 and at what? At 3. So any questions there before we find the y-intercept? Okay, so if there are no questions, let's find the y-intercept now. So the y-intercept, remember we said we need x to be 0. So y-inter, we find it when x is 0. So there in f of x, okay, I'm just going to say 0 is equals to, remember this f of x is equals to y, right? So I can even start it as y is equals to the f of x, but the f of x, the x that I'm considering is 0. Then it will be 0 squared minus 5, 0, plus 6. Okay, so it means my y-intercept is just 6. So I can put it there. That is my y-intercept. If you want, don't even do this. Okay, it's like you're wasting time here. Just get the constant there. That's all. Okay, so we're just remaining with the turning points now. So the turning point, okay, we start with the x coordinate of a turning point. So we said the formula was minus b over 2a. So now minus, and then what is my b here? Remember the general form, ax squared plus bx plus c. So it means my b here is this minus 5. Okay, so I'll put minus 5 over, what is my a? So I have 2 multiplied by a. My a is the coefficient of x squared, which is just 1 there. So I'll put 1. So this will be negative multiplied by negative, that is 5 over 2. Okay, so this here is my x coordinate of a turning point. So now, how do we find the y coordinate of a turning point? We said we get this same value here, then we replace it into this equation. So I'm going to say the y coordinate of a turning point is equals to f of, the x now is 5 over 2. It's equals to 5 over 2 squared minus 5 multiplied by 5 over 2 plus 6. So this will give me 5 squared will be 25 over 4 minus, here to be 25 because I'm multiplying 5 by 5. So that will be 25 over 2 plus, then here to be 6. Okay, so that is what we have. So now we can try to add these. Okay, so let's add them. So we have y is equals to 25 over 4, okay, minus this one. We can also make it as a number to have a denominator 4 so that we easily add the fractions. So what do I do? I multiply 25 by 4, even this one by 4. But if you want, you can do it in the general way. Okay, I'm just trying to make it simple. So if I multiply this one, the 25 by 4, I'm going to get 100. And then if I multiply 2 by 4, oh, no. We are multiplying by a 2 because we want to make this here to be 4 like this one. So I multiply this one by 2, I get 50 over, if I multiply the 2 by 2, I get 4. So this 50 over 4 is the same as 25 over 2. So if you want, you can solve it like this, okay? But I'm just trying to make it simple. And then plus, here, this 6 is over 1. So I want this denominator to be 4 like the others. So what do? I multiply the 6 by 4, even the 1 by 4, which is down. So I get 24 over 4. Okay, so now you see here, the fractions, I'll add them easily because I have the same denominator. So this 24 over 4 is the same as 6. So I'll put common denominator is 4. And then all these 4 will be going once here. And then when they multiply, whatever is on top, don't change anything. So it will just be 25 minus 50 plus 24. So this will be 49 minus 50 over 4. So the answer here will be what? Minus 1 over 4, right? Okay, so that will be our our y coordinate of a turning point. So we're going to write it here. Turning point is just the x, remember, found 5 over 2. The y we found minus 1 over what? 4. So we have the three things that we need. X coordinates, x intercepts, y-intercept, turning point. So we can sketch this guy now. So let's do that. Okay. So let's sketch him. Okay, so sketching, we're just plotting those things here. Okay, so I have my y. I have my x. So we have a 2 and a 3, a 6 going in the y's. Okay, so this is 0. You can say 1, 2, 3, and then 4. Okay, or maybe I should space them a bit. So I say maybe my 2 is there, my 3 is there. Okay, that's better. And then going up in the y's here, okay, I can put my 6 somewhere there. And then the turning point is 5 over 2. 5 over 2, what is 5 over 2? 5 over 2 is 2.5. Okay, and then minus 1 over 4, that is like what now? Okay, so minus 1 over 4 hits minus 0. Okay, I forgot the minus. It's minus 0.25. So you check on your calculator, this one and this one. So this is our turning point. So let's plot the turning point. So the turning point will be 2.5. 2.5 will be between these two, right? Okay, and then going down, I'm going to minus 0.25. So minus 0.25, you can say it's somewhere there. So we can say minus 0.25 there because it's in the negative y's now. And then the 2.5 is in between here. So if I plot the turning point, it will be there. So that is my turning point. This is 5 over 2, comma, minus 1 over 4, or 2.5, comma, 0.25, this one. And then our x-intercepts, we can see them clearly here. We have 2 and 3 from here. And then my y-intercept is that one, which is 6. Okay, so we've plotted whatever we needed. So now we just connect this with a smooth curve like that. So forgive me if my curve is not smooth, okay, but we just have to connect these points now. Look at me now. Like that, and then it touches this, and then start going up like that. Okay, so this curve here is our curve of f of x is equals to x squared minus 5x plus 6. We've sketched it. Okay, so any questions there? Any questions there, guys? Before I show you the completing the square one.
No.
All right, so now let's complete the square and then see how it's done. So for any quadratic equation that you can be given, just follow the same steps, you'll be able to come up with the graph, okay? All right, so let's try now to use completing the square. So please pay attention as we complete the square, okay? So the original question that we were given was x squared minus 5x plus 6, right? So we want to complete the square on this one. So we just want to express it in a special way, okay? So how do we do that? Okay, so follow the steps. So I'll say equals here, and then I'll write this one and this one the way they are, okay? So I'll just write x squared minus 5x, okay? Then I pause. So now, what is the next thing to write? I'm going to say, okay, I'm going to say plus, okay? And then I'm going to get the half of the coefficient of x, okay? Half the coefficient of x, I'm going to square it, and then I'm going to say minus the same thing. So what I mean is that I'll say plus, and then in brackets, I'm going to get the coefficient of x. So the coefficient of x here is what? Minus 5. So I'll get minus 5 and put it there. Then I'm going to divide it by 2. Okay, so don't ask me where is the 2 coming from. It's that's the way it should be done. Okay, it's in the formula. So I'll get the coefficient of x divided by 2, and then I'm going to say square. Okay, and then after I do that, I'm going to say minus the same thing that I've written here. Okay, so I'll write it again, minus 5 over 2 squared, and then I'm going to say plus 6. So now, notice what I've done. I've created something that we call as a special zero. It's a zero, but it's been expressed in terms of numbers. Okay, so this part here in green, this is just a special zero. It's a zero. So I haven't changed anything to this equation which is on top here because this is zero, because it's the same thing that is there, and then it has plus and minus. So it will cancel out. It's like 2 minus 2. We know this is zero, right? So it's exactly what I've done there. So I've created what we call as a special zero. So when you do that, okay, when you do that, it leads you to have what we call as a perfect square. Okay, it leads you to what we call as the perfect square. So now notice this. Okay, look at this. If I have x minus 2 and then I say squared, when I expand this, it's going to be what? It's going to be x multiplied by x, I get x squared. X multiplied by minus 2x, I get minus 2x. So I'm done with the x. I go to the minus 2. Minus 2 multiplied by x, I get another minus 2x. So when I combine this, I get what? Minus 4x. And then now multiply minus 2 multiplied by minus 2. I get what? Plus 4. So we see that this guy here can also be expressed as this guy, right? Okay. So this one is a perfect square. Or we can say this one guy is also a what? A perfect square. I can express this as this. So notice that um, this 4, that is at the end, okay? I can write it as I'll erase the 4, and then I'll write it in another way. I'll write it as 2 squared, okay? So notice that when we are writing it in this form, it's like we're ignoring this part. We're just getting the x there without the squared, and then we get whatever is here, okay? Um, okay, so no. Let me do this. This one here, the one that I've squared here, is the same as, okay, it's the same as the minus 2 squared. We know minus 2 squared is just going to give us 4. Okay, so now notice that it's like we're ignoring this guy here. I'm back to my point now. And then we're just getting the y here, I mean the x there, we are leaving out the squared. And then here we come and get whatever is inside there, which is minus 2. Okay, and then we put these ones in brackets because they are the square here and the square there. We say squared. So this guy, which is the same as this, can be represented as this, right? Okay, so that's the same thing that we are going to do here. We notice that these three terms here, these ones here that are boxed in a yellow, they form what we call as a perfect square. Okay, so just like here, I'm going to ignore this part, the minus 5x. So this one will just collapse to, I get the x, okay, with the squared, I just write it as x, and then I come and get whatever is inside the brackets there, becomes minus 5 over 2. And then since this one are the squared, even this one are the squared, I say in brackets, and then I square. Okay, so this thing here, the first three terms, y squared minus 5x plus minus 5 over 2 squares, have collapsed into a perfect square like that. That's what we call as completing the square. Okay, so I hope you won't get confused. So always, the trick that I've used here is what you should be using. Okay, I was just using whatever was here to explain. And then what remains, okay, I have minus. This one is still, here we can square it now. So we can say minus 5 squared. I'll just get what? 25 over 2 squared, I'll get 4. And then I have plus 6 there. Okay, so this is what I have. And remember, this is equals to f of x, of course. So this is equals to, here I have x minus 5 over 2 squared. And then here, if I multiply this negative with this, I get what? Minus 25 over 4, and then plus 6. Okay. But remember, I said 6 is the same as 24 over what? Over 4. So I can replace this 6 with 24 over 4. Okay, but if you want, just add them like that. Okay, I'm just adding it there so that my addition of fractions should be easier. So the 6 which is here is the same as this. So I write 24 over 4. Okay, so what do I have? Here I have the same denominators. So I can just add minus 25 to plus 24. So what I get here is x minus 5 over 2 squared. And then this part here just becomes what? Minus 1 over 4. And we are done. We have completed the square. Okay, so it means this part here can also be written as x minus 5 over 2 squared minus 1 over 4. So we've completed the square on this guy to form this. Okay, so now let's erase. And then from the completed the square form, we can get our turning points, we can get our y-intercept, we can also get our x-intercept. Okay, So let's start with the turning points. So the turning points will be, I said the x coordinate, you get whatever is inside the brackets here. You equate it to 0 and then solve for x. So it will be x minus 5 over 2 is equals to 0. So x will just be equals to what? 5 over 2. So you see that this value, it's the same that we got when we use this formula. It's the same thing, this one. Okay. What about the y coordinate of a turning point? Okay. So we said the y coordinate of a turning point happens when you evaluate this function at x is equals to 0. So this one will be 0 minus 5 over 2 squared minus 1 over 4. So here it will be 0 minus this, it will just be minus this over 4. So this will be like 25 over 4, then minus 1 over 4. So we have common denominators there, which is nice. So it will just be 25 minus 1. This is 24. And this is what? 6. You notice that it's the same as um, uh, the y-intercept. Okay, so this is the y-intercept, not the y-coordinate of a turning point. Sorry, I got confused. So the y-intercept is still 6, just like in the original equation. Okay, so I got confused there. I was finding the y-intercept instead of the y-coordinate of a turning point. Okay, so the y-intercept is 6, so found it there. Okay, and then now how do we get the y coordinate of a turning point? I just said you get whatever is there. So y is equals to minus 1 over 4, which is the same value that we got, right? For the y coordinate of a turning point. So the turning point is just this, comma this. Okay, the y-intercept is this, and then for you to get the x-intercepts, okay, so x-intercept, we said f of x should be equals to 0. So remember, f of x is equals to this guy. So now the f of x is 0. So it means I have this being equals to what? To 0. Okay. And then from there, I can solve for x. So it will be x minus 5 over 2 squared is equals to 1 over 4. We take the root on both sides, root on both sides. So what do we have? We have x minus 5 over 2. This and this root cancels. Here, I'm going to get plus or minus. Okay, here it's 1 over 4. So the root of 1 is just 1. And the root of 4 is just 2. Okay, so it means my x will be what? I'm taking it here now. So x will just be, this minus 5 over 2 goes to the other side. So it will be 5 over 2 plus or minus half. So if we get the plus to be 5 over 2 plus 1 over 2, this will just be 6 over 2, which will be give 3. If we get the minus to be x is equals to 5 over 2 minus 1 over 2 is equals to 5 minus 1, it's 4 over 2, which is 2. So you see that even the completed the square one gives our x-intercept as x is equals to 2 and x is equals to what? To 3. Okay, so we have the turning point here, y-intercept, x-intercepts from this formula. Okay, so it's very easy to get the turning points from here because you just equate this to 0 and then for the y you just get whatever is there. Okay, so once you have these points, then you can go on and sketch your graph. Okay, so we already sketched it, so I'll just sketch a rough one. Okay, so we have 0 there. We have minus 0.25, which is this one. And then I can say 2 there, 3. So the 2.5 is somewhere here, which is 5 over 2. And then I have the 6 somewhere there. Okay, so to sketch it, I'm just going to draw a line that passes through these points like that. So turning point there, like that. And this will be x minus 5 over 2 squared minus 1 over 4. Okay, and we are done. So any questions there? Any questions there, guys? Okay, so now let's look at more questions on how we can graph quadratic equations using completing the square. Okay, so here the question is saying express each of the following quadratic functions in the form a x plus p squared plus q, where a, p, and q are constants to be found. In each case, write down the turning point and then sketch the graph of the quadratic, showing clearly the coordinates of the points where the graph crosses the coordinate axis. So here by coordinate axis, okay, they just mean the x-axis and the y-axis. So the points where they cross the y-axis, okay, will be termed as the y-intercept. The points where they cross the x are just the what? The x-intercepts. Okay. And then also to graph a quadratic, remember, we always have to find the what? The turning point. So on all these questions here, okay, we'll be specifically looking for three things: y-intercept, x-intercept, turning point. Then we can sketch. Okay, let's look at the first one. So this one on A, okay. So the first thing is to complete the square. Okay, so now let me tell you a secret. When you're completing the square, always make sure, okay? Always make sure that the coefficient of x squared is 1, okay? If it's not 1, then we can't complete the square, okay? So the coefficient of x squared, this guy here, always have to be a positive 1, not a negative 1, not 2, not 5, not any number. It has to be always a positive 1. So if it's not a positive 1, like the way most of these questions you are seeing here are, we have to make it to be a positive 1. So what do? Okay, we factorize. So here I'm going to say this is the same as this 2. I'll factorize it from here so that I just remain with a positive x squared. Okay, so if I factorize a 2 from here, it means I should also factorize it from there. I should also factorize it from here. Okay, so if I factorize a 2 from here, I'm just going to remain with 4x. If I factorize the 2 from here, I'm going to remain with 3 over what? Over 2. Okay, so when you factorize, make sure that when you multiply this number that you've put outside with whatever you have inside, you get back what you have here. Because if I do this times this, I still get 2x squared. This times this, I get plus 8x. This multiplied by this, I get minus 3. So I'm correct. Okay, so now when you make the coefficient of x squared to be 1, okay, it means you can complete the square with this term that is inside there. Okay, so completing the square, what did we say? Okay, we write x squared plus 4x, okay, and then we say plus, we create a special 0. So we're going to get the coefficient of x, which is 4, you divide it by 2, and then you square. And then you say minus, you write the same thing here. So 4 over 2 squared, okay, and then you write now whatever you had there, minus 3 over 2, like this. Okay, so you notice that this part here is just a 0. So we haven't changed anything. Okay, now we're just going to group these things differently. So the first 3 terms here, they're going to form what we call as a what? A perfect square. Okay, so I'm going to say outside I have 2, open brackets. Here, I'm going to ignore the term with the x. So I'll just write x, and then I get whatever is inside the brackets here. So this is 4 over 2, which is the same as 2. So inside the brackets here, I have a positive 2. So I'm going to write plus 2, okay, and then squared. So you only considered this and this. This one, you ignore it, okay? I've already explained the concept. And then here I'll say minus. Inside here, we have 4 over 2, which is 2. So 2 squared is what? 4. And then I have minus 3 over 2. Okay, so it means my f of x will just be equals to 2, and then I have x plus 2 squared, okay, and then now I can combine these. So I have minus 4 minus 3 over 2. So I can make this guy to have a denominator of 2 as well. So how do I do that? Okay, I just write it as minus 8 over 2. Minus 8 over 2 is the same as minus 4, right? So I'm just doing this so that I can add the fractions easily. But if you want, just add the normal way. So I'll write 2, and then there I'll just have minus 8 minus 3. So it means here I would have minus 11 over 2. So I'll write here minus 11 over 2. Okay. And then once you're done now completing the square, you can multiply with the number that is outside there. So this multiplied by this to be 2x plus 2 squared, 2 multiplied by minus 11 over 2 to just cancel out the 2. So I remain with minus 11. So this is the completed square form of this equation here. So what are we going to do with it? We're going to use it to find the turning point, okay? And then the x-intercept. Because the y-intercept, we can just easily get from there. Okay, so I'm going to say turning points. So turning point, we said the x-coordinate, just get whatever is inside, equate it to 0. So for x, so that is minus 2. And then for the y, we just get whatever is outside there. So that is minus 11. So the turning point will just be minus 2, comma minus 11. That's all. Okay. What about the y-intercept? So y-inter is just whatever is alone there, the constant, minus 3. But if you want, you can find it. You can say, let's try to put 0 where there's x there. Okay. So here it will just be 0 plus 2. So it will be 2. 2 squared, okay, it's 4. 4 multiplied by 2, which is outside, it's 8. So this here will become 8 minus 11, which is just minus 3. So that is my y-intercept. Okay, but you don't have to waste time. Just look at the constant. Okay, and then after that, we can now find our x-intercept. Okay, so our x-intercept, we said we make what? F of x to be equals to 0. So f of x is equals to 0. It means this whole thing here will be equals to 0. Okay, so it will be 2x plus 2 squared minus 11 is equals to 0, which will just be 2x plus 2 squared is equals to 11. Okay, divide by 2, divide by 2, I get x plus 2 squared is equals to 11 over 2. Okay, at this point, I'm going to square both sides. I'm going to square root both sides. So I'm going to say the square root of x plus 2 squared is equals to. So now on the right, when I introduce a square root, then I'll get plus or minus the square root of, I have 11 over what? 2. Okay, so here the square and the square root will cancel. I have x plus 2 is equals to plus or minus the square root of 11 over 2. So here would just be x is equals to minus 2 plus or minus the root of 11 over 2. So this is what I have, right? Okay, so from what I have there, I can get my x-intercept. So the first one will go with the plus. So it will be x is equals to minus 2 plus the root of 11 over 2. The other one will be x is equals to minus 2 minus the root of 11 over what? 2. Okay, so now we have to find an approximate value, okay, for these x values. So the first one, okay, we have a minus 2 and then plus the root of 11 over 2. So when you punch that on your calculator, okay, to be minus 2 plus the root of 11 divided by 2. Okay, so approximately that is giving me, it's giving me what? It's giving me 0.35. Okay, what about this one here where we have a minus? Okay, that one will gives me minus, approximately minus 4.35. Okay, so now we know our x-intercepts, we know our y, we know our turning points. We can sketch this graph. Okay, so to sketch, okay, let me put it here. We're just going to get, this will be our y. Okay, so our y goes all the way to minus 11. So it will be my x. Okay, so this is my y, this is my x. Okay, there I have a 0. So our turning point is this, y-intercept, x-intercepts. So x-intercept, okay, this is 0.3. So 0.3 will actually be before 1, right? So if my 1 is somewhere here, my 0.3 can be somewhere there. And then here, we're going all the way to minus 4 point something. So if this is minus 4, minus 4.35 is somewhere after here. Okay, so let's plot them. So minus 4.35 is there, 0.35 to be somewhere there. Okay, those are my x-intercepts. And then my turning point is minus 2, comma minus 11. So minus 2 should be somewhere here. Okay, we can just put it somewhere there. Then minus 11, okay, we can just say this is our minus 11 here. Okay, so minus 11. So minus 2, comma minus 11. That is my turning point, this one here. Okay, and then um my y-intercept is minus 3. So it can be somewhere here. Okay, so after I do that, we just draw a smooth curve along these points now. Okay, so the turning point is down here. So it means my curve will actually start from above there and then to go like that. Okay, so to just come from there, pass to that point here. At this point, it will turn. Okay, this point it will turn, pass through the y-intercept, then pass through the other x-intercept. So this graph here is for my f of x, which is equals to 2x squared plus 8x minus 3. Okay, so that's how we do that. And we're going to be doing the same for all these other questions. Okay, so let's look at B. So B, we first complete the square, right? Okay, so B, we have f of x is equals to 5x squared minus 15x plus 7. So I said the first thing, to complete the square, you always have to make sure that the coefficient of x squared is positive 1. So I'm going to factorize the 5. So if I factorize it from the x squared, I also factorize it from minus 15x, even from the 7. So if I factorize it from the minus 15, I mean with minus 3. If I factorize it from the 5, I get 7 over 5. So make sure that when I multiply this and this gives me that, this and this gives me that, this and this gives me that. And then now I can complete the square inside there, right? Because here it's positive 1. Okay, so what I'm going to do now is I'm going to write x squared minus 3x, okay, and then I will say pause. And then I create my special 0. So it will be plus, okay? So you always get the coefficient of x. So coefficient of x is minus 3 over 2 in the brackets square. And then you say minus the same thing, square, okay? And then I continue with my plus. I continue with my plus 7 over 5. Okay, so that's what we do there. That's what we do there. Okay. And then from there, we see that those terms in green, okay, those terms in green, they're just a special 0. Okay, those terms in green, they're just a special 0. Okay, and then the first 3 terms now, these ones here, they're going to form a perfect square. So it's always like that. Okay, as long as you get the coefficient of this, you divide it by 2 and then you square it. So this one will just be 5. And then here we just have to ignore the term with the x. We just consider this one which is squared here. So it will be x, and then I get whatever is inside here, which is minus 3 over 2 squared. Okay, so I'm done with the first 3 terms. And then there to be minus 3 squared to be 9, 2 squared to be 4, then plus 7 over 5. So that is what I have. So I just have to combine these terms now. Okay, I just have to combine these terms. So what am I going to do there? Okay, what am I going to do there? Okay, so now let's add these guys. So it will be minus 9 over 4 plus 7 over 5. So common denominator here is what? 20. So 4 into 20, it's 5. 5 multiplied by minus 9, I'll get minus 45 plus 5 into 20, it's 4. Then 4 multiplied by 7, I get 28. Okay, so I have a minus 45 plus 28. Okay, so that gives me minus 17 over 20. Okay, so it means this function to be f of x is equals to 5 outside, and then I have x minus 3 over 2 squared, and then minus 17 over 20. So from here, I'm now going to multiply this 5 throughout. So it will be 5x minus 3 over 2 squared, and then 5 multiplied by 17 over 20 to just be 17 over 4. Okay, because just say 5 into 5, 5 into 20. So this is my completed the square form. And then from here, we can get our turning points and our x intercepts, because the y-intercept is just the 7. Okay, so y-inter, or let's write it as 7. Turning points, okay? So if I equate x minus 3 over 2 to 0, just get x is equals to 3 over 2. So that will be my x coordinate. Then my y coordinate is whatever is outside here. So that will be 17 over 4. Okay, so you can actually get the approximate value of this so that you know the decimals. So 3 over 2, this is 1.5, comma, 17 over 4. That's 4.25. Okay, so those are our turning points and y-intercepts. What about the x-intercepts? So the x-intercepts, we need f of x to be 0. So this is 0, and then it's equating to this. So it's like we have 5x minus 3 over 2 squared minus 17 over 4 is equals to 0. So this will be 5x minus 3 over 2 squared is equals to 17 over 4. Okay, so I'm going to divide both sides by 5. So if I divide this side by 5, it cancels. So I have x minus 3 over 2 squared. If I divide this by 5, what do you think I get? So it will be 7 over 4 divided by 5. Okay, so this will just be 17 over 4 multiplied by, then this one goes on top. This 5 comes down. So it will be 1 over 5. So this will be 17 over 20. Okay, so it's equals to 17 over 20 when you divide it by 5. Then from there, we're going to take the square root. Even here, the square root. But when you take the square root on the right hand, okay, you have plus or minus. So this will be plus or minus the square root of this. Okay, here, the 2 and the square root will cancel. So I have x minus 3 over 2 is equals to plus or minus the root of 17 over 20. Okay, and then from here, I can get my two values of x. Okay, so my first one will be what? Okay, so the first one will be x is equals to 3 over 2 plus or minus the root of 17 over 20. So this will be x is equals to 3 over 2 plus the root of 17 over 20. The other one will be x is equals to 3 over 2 minus the root of 17 over 20. So you can find the approximate values of this. Okay, so you check with your calculator. So we're going to say 3 divided by 2, 3 divided by 2 plus root of 17 divided by 20. Okay, so my calculator is giving me an approximate value here of 2.42. So what about if we subtract? Okay, what about if we subtract there? So let me do that. So if I subtract, I'm getting approximately 0.78. Okay, so these here will be my x values or my x-intercepts. So I can write them here. Okay, approximately. Okay, so now I have everything that I need in order to sketch. Okay, so I have my y and then my x. So this is 0. Okay, so what numbers can I see? In my y, I can see 7. I can see 17 over 4, which is 4.25. Okay, right. So here I'll just say 4 is somewhere there, and then I have 7 somewhere there. Okay, and then in my x, I have 0.58. 0.58, this is my one. Okay, 0.58 should be somewhere there. Okay, and then what else? My other x-intercept is 2.42. So if this is my 2.42 should be somewhere there. Okay, what about my turning point? It's 1.5. 1.5 is somewhere here, comma 4.25. So for my 4.25 should be somewhere there. Okay, so this is my turning point here. Okay, and then what else? Uh, my okay, my y-intercept. So y-intercept is 7. Okay, so did we find the correct thing here? Because the y-intercept is showing like it's there. Okay, so how do we draw um okay. Okay, so I think we made a mistake on the turning point. No wonder it's not making sense because how can a graph turn here and then the y-intercept is there? Okay, so we made a mistake here. Remember, um, here, this one here was minus 17 over 4 and not positive. So this is minus. So this one should be minus there. Okay, so this point here will come somewhere down. Okay, to be somewhere down here. So it will be 1.5 comma. So if this is minus 4, to be somewhere here. Okay, so I made a mistake there on the turning point. This was minus. Okay, so take note. And then now this one should make sense. Okay, because there's a y-intercept, it coming, passes to the x, and then it goes like that. So I'm just going to draw my graph through these same points. So just draw a small curve. Turning point is there. Okay, let me draw it again. Like that. Okay, so this will be the curve of this guy here. All right. So now let's look at another example. Okay, let's look at another example. Okay, so now let's look at another example. Okay, so here we looked at question A and B, and you can see that C will actually follow the same pattern. So let's look at something different, like this one here that has a negative in front there. Okay, so I'll also look at two of these, and then the other one you can try it out. So try out this one, uh, and then you can send to me, and then I can confirm. Okay, so let's look at that. So we have which one now? Okay, let's look at D. So D is being given as f of x is equals to, you can start with minus 4x squared, and then minus 16x plus 11. So the first thing is always to make the coefficient of x squared a 1. Okay, so I'll factorize the 4, the minus 4. So if I factorize the minus 4, I remain with the x squared. Here, if I factorize the minus 4, what do you think I remain with? I remain with plus 4x. Here, when I factorize the minus 4, I'll just remain with minus 11 over 4. So make sure that when you multiply this and this gives you that. This and this gives you that. Okay? This and this, it gives you that. Okay, and then now we can uh, complete the square. Okay. Okay, so this will be minus 4. And then inside here, we write x squared plus 4x. Okay, and then after that, we write the special 0. So it will be plus, and then we get the coefficient of x, which is 4, divide it by 2, and then we square minus the same thing. Okay, and then we continue with our minus 11 over 4. Okay, so it means here we have minus 4. And then here, the first three terms here, they form a perfect square. So we ignore the one with the x. So it will just be x. Okay, and then we get whatever is inside the brackets here. So 4 over 2 is just 2. And then this will be squared, and then minus this part now. So 4 over 2, it's 2. 2 squared is 4. So it will be 4. Then minus 11 over 4. So we can try to add this here. Okay, so this is 4. And then this is 11 over 4. So I can make this to be over 4 by writing it as minus 16 over 4. Okay, minus 16 over 4 is the same as 4. And then minus like that. So I can add this, so it will be 4, and then minus 16 minus 11. So this will be minus 2, 7 over 4. So it means our completed square form will be f of x is equals to minus 4 x plus 2 squared minus 27 over 4. Then from here, we can distribute this minus 4. So to be minus 4 multiplied by this, I get minus 4 x plus 2 squared, and then minus 4 multiplied by minus 27 over 4. The minus and the minus will cancel, and the 4 will cancel. So I'll just remain with plus 27. Okay, so that's the completed square form for this quadratic. Okay, so from here, we can get our turning points. Our turning point will just be, I equate this to get the x, equate it to 0, so it will be x is equals to minus 2. So it will be minus 2, comma. My y coordinate of a turning point will just be whatever is there, so which is 27. Okay, what about the y-intercept? The y-intercept, we just get it from here, the constant. So that will be 11. Okay, and then we now find the x-intercepts by making this f of x here, this one to be 0. So it's this whole thing is equating to 0. Okay, so it will be minus 4 x plus 2 squared plus 27 is equals to 0. So it will be minus 4 x plus 2 squared is equals to minus 27 over 4. We divide by minus 4 on both sides. We end up with x plus 2 squared is equals to minus 27 over minus 4. But the minus and the minus cancel. So what we have is x plus 2 squared is equals to 27 over 4. Okay, and then when we reach here, we square root on both sides. Square root this side. Here, when we square root, we're going to have plus or minus the square root. Okay, so it will be x plus 2 is equals to plus or minus the square root of 27 over 4. So it will be x is equals to minus 2 plus or minus the square root of 27 over 4. Okay, from here we can get our two answers for the x-intercepts. Okay, can get our two answers for the x-intercepts. So I'm going to say x, okay, let me write it here. X is equals to minus 2 plus root of 27 over 4. X is equals to minus 2 minus root of 27 over 4. Okay, so we have to find the approximate values for these. Okay, so this one will just be what? So we have minus 2. Okay, minus 2 plus the root of 27 over 4. Okay, so that gives me approximately 0.6. Then this one approximately, when there's the minus there. So minus 2 minus root of 27 over 4 is giving me minus 4.6 approximately. Okay, so those will be my x-intercepts. This is my y. and then this is my these are my turning points. Okay, so I can sketch this. So I can write the x-intercepts here. Okay, so let's sketch. Okay, so on the turning point, I'm going as far as 27. You can see here, this is 27. Okay, so it means up there on the y's, it has to be a bit longer. Okay, and then I have the x here. Okay, this is the y, this is the x. So this is the 0. So I have 0 0.6. 0 0.6 can be somewhere here. Okay, if my 1 is somewhere there. And then I have what? I have minus 4.6. So if this is minus 4, minus 4.6 will be somewhere there. Okay, and then the turning point is minus 2, comma what? Minus 2, comma 27. Okay, so minus 2 can be somewhere here. Then 27 should be up there somewhere. So 27. So the turning point can be there. And then the y-intercept is 11. So it can be somewhere there. So my graph will just be a smooth curve that passes through these points like this. So turning point, y-intercept, and then another x-intercept like that. So this is my y-intercept there. Okay, so this graph will be the graph for 11 minus 16 x minus 4x squared. Okay, so we have sketched it. Okay, okay. So now let's look at one more example, then we'll be done with this video. Okay, so I have this one and this one. So I'll leave one for you. Okay, so F, I'll leave it for you, just like I left C. So if you have any questions, okay, you can inbox me on the number below. Okay, or you can try to solve it and then inbox me to see if you're doing the correct thing. Okay, so let's look at E. So E, okay, the first thing is to factorize the minus 2 so that the coefficient there of x squared should be positive 1. So it will be minus 2, and then remain with x squared. Okay, if I factorize the minus 2 from there, I'll remain with the minus x. If I factorize the minus 2 from here, I'll remain with the minus 1 over 2. So just make sure that when you multiply minus this multiplied by this, I get this. This multiplied by this, I get this. This multiplied by this, I get 1. Okay, so this will be equals to minus 2. And then here, I complete the square now there. So it will be x squared minus x. Okay, then we create a special 0. So it will be plus, what's the coefficient of x? It's minus 1. So it's minus 1 over 2 squared, then minus 1 over 2, the same thing. Okay, and then I write minus 1 over 2. Okay, so the first three here form a perfect square. So that is going to collapse to what? The x, we ignore it, the term with x. Just focus with the ones that are squared. So it will be x, and then I get whatever is inside the brackets here, which is minus 1 over 2 squared. And then say minus here, the minus 1 squared, that is 1. Minus 2 squared, that is 4. Then I have minus 1 over 2. So I need just to add these here. So I have minus 1 over 4 minus 1 over 2. Okay. Uh, okay, so let's add. So 4 common, 1 minus 1 minus 2. There to be minus 2, right? Okay, because there to be 2 multiplied by minus 1 minus 2. So this here will just be minus 3 over 4. So it means my f of x just be equals to minus 2, okay? And then x minus 1 over 2 squared minus 3 over 4. Let's multiply with this. So it would be what now? It would be, okay, to be minus 2x minus 1 over 2 squared. And then minus 2 multiplied by minus 3 over 2 give me positive 3 over 2. Okay, so from I completed the square form, I can get my turning points. So turning points, okay, will just be, I equate whatever is in the brackets to 0 to find the x-coordinate of a turning point. So it's half, and then the y-coordinate of a turning point is whatever we have there. So it will be half, and then 3 over 2. Okay, and then what else? Y-intercept. So the y-intercept, we just get it from the question here. So which is just 1. So it's 1. And then the x-intercept, okay, we make this f of x here to be 0. So equating this whole thing to 0. So it will be minus 2x minus 1 over 2 squared plus 3 over 2 is equals to 0. This will give me minus 2x minus 1 over 2 squared is equals to minus 3 over 2. Divide both sides by minus 2. I get x minus 1 over 2 squared. Okay, if I divide this by minus 2, I'll get 3 over 4. And then from here, we square root. Square root this side, I get x minus 1 over 2. Square root the other side, I get plus or minus the square root of 3 over 4. So it means my x values will just be x, okay? Just be half when I take this half to the other side. And then I get the positive of this, which is plus 3 over 4 is equals to. Then the other one is x is equals to half minus the root of 3 over 4 is equals to. Okay, so these ones I'll just get the approximate value from the calculator. Okay, so I have 1 over 2 and then plus, okay, plus the root of what now? Plus the root of 3 over 4. Okay, so this will be 1 plus 3 point, oh, 1.4 approximately. Okay, if we put a plus, a minus there? So if I put a minus, it's giving me 0.4 approximately. Okay, so we have everything that we need now. We can sketch this graph. Okay, so this is our y, this is our x, this is my 0. So let's try to plot these points. Okay, so this is minus 0.4. So if my minus 1 is there, my minus 0.4 should be somewhere there. Okay, should be somewhere there. And then my 1.4, if this is 1, 1.4 should be somewhere there. Okay, I've plotted my x-intercepts. My y-intercept is 1. And then my turning point is half, comma, 3 over 2. So 3 over 2 is the same as 1.5. Half is the same as 0.5. 3 over 2 is the same as 1.5. Okay, so let's plot this. So 0.5 should be somewhere here. Okay, then 1.5, if this is my 1, then my 1.5 should be somewhere there. Okay, so I have 0.5, comma 1.5 here. So that's my turning point there. Then this is my y-intercept. So I just drew a curve now, a smooth one that connects this. Come like that. Okay, so this one here is the curve for minus 2x squared plus 2x plus 1. Okay, so we are done. Okay, so that's how you can sketch the graphs easily, okay, by completing the what? The square method. Right, so thank you so much for watching. If you'd like to access more videos on different mathematics topics, chemistry, biology, and physics, feel free to register with us. Okay, so in the link here in the description, you find a link to our website. So our website has videos on all the topics and you can learn anytime. And you also find a link to our mobile app. Okay, so on the mobile app, you'll be able to download the videos and you can even watch those videos offline. Okay, you're in your blankets, you are learning. So feel free to register with us. And for any questions, please reach out. Okay, my number is also in the description below there. So this has been Tutor Solutions. Until next time.